Hello, everyone. Good afternoon. I'm very happy to see you all here. And thanks for giving me 20 minutes of your time to hear me talk about API design. And before we start, let me introduce myself. My name is Teresa Wu. I'm a software engineer who likes the sound of DevOps, Agile, continuous delivery, efficient release, and test automation. So today I'm going to talk about API design, but mostly I'm going to focus on API design for front-end engineer, right? You might be wondering why. So hear me out. I will explain you why, right? So let's kick off. So let's talk about what is API first, right? I'm sure you all know about it. In case that you are not, so API basically is a bridge between backend and frontend project. So in the past, web application is just few pages of HTML, and frontend is actually less mentioned. So API wasn't a key element in project design. Along with the invention of microservice and front-end project has then diverged into web, mobile, desktop. So since then, right, API design has become a very important subject. But should API design be the responsibility of backend engineers? I mean, yes, they are the one usually talks about it very often, and they probably care about it as well because they have to implement it. But should they be responsible for how efficient and how to optimize the API for front-end applications? So usually when there's a provider, there's a consumer, right? So we, as a front-end engineer, we are actually the consumer of the API. So we should be also part of the API design. We should actually care about it probably even more than backend engineer. But through my own experience, right, I do notice API design is kind of forgotten or ignored by front-end engineer. So today I'm going to talk about how we design API together with backend team and how we're going to test API in the end. So you probably heard this phrase before. So we should always design API as user experience, right? We treat API independently from implementation. So feel good practice of API design. We have the URL structure, the request method, header, the versioning, pagination, the JSON syntax, and the error code and the status code, right? And I'm going to talk about each of them in the next few slides. So first, the URL structure. Let's say, right, you should always use noun instead of verb. The only time you use the verb is actually through the HTTP request itself, because you always want to either get, retrieve, set, or modify a resource. And the resource itself is always a noun and probably a plural form as well. And always use query if you can, instead of using subdirectory. And a good URL should be less than 2,000 character long. And you should avoid having breaking changes very often. Any breaking change should be communicated beforehand, because those breaking change might end up break your app. So this is an example of how a quite well-structured URL looks like. It starts with a scheme. It could be either HTTPS or HTTP, but HTTPS is highly recommended, right? Followed by the domain, and you have also the directory as well. So it doesn't mean you never use directory. You always have directory, but try to have less nested subdirectory. Followed by a query, which is the question mark. Then you can do some query, giving some value and separate it, attach more query to it. Like for example, right, in this case, I want to search for location which is in London, and I want to also sort it. So once you have your URL structure set, the next thing you want to think about when you design your API is the API versioning. There are four ways you can version your API, four major ways, right? First is the query. It's quite easy, but it's difficult to route requests to the proper API version. And then you have the embedded in path, right? It allows you to update all the API paths for any breaking change. So it's actually quite widely used method. Or you can do content negotiation. I do this less often though, but you can use it. So it's kind of a bit harder to test, but you can version a single resource instead of the entire API. So it's quite handy in a way. And another thing is a header. This one is also quite widely used. You can version the API through header. So it doesn't clutter the URI with versioning information. But once you set it, you might have to apply it for multiple API calls. So give you less flexibility if you have a project that you might want to use different versions of the API through different API functions. So think about what kind of versioning you want to use, apply them, and set with it, right? Don't use a combination of all. So pick one and perhaps maybe just stick with it. And then let's look at some of the request method. So there were six major ones, right? I'm sure you're probably familiar with a few of them for sure, like get, post, put, delete, right? I'll talk about patch and the search here. So patch is actually very useful. You probably see patch now more often than put. It's kind of replaced the function put already. So it's similar with put. But imagine if you have a user object, right? With a put, you kind of update the entire resource of all the fields of the user object, the first name, the address, the email. What if you only want to update just the email address, right? So with patch, it allows you to just update a single field of a very big object. So it's more efficient, saves you some of the resource as well. Sorry, I'm sneezing. Okay, so the next method I want to talk a bit here is the search. It's a kind of new released HTTP method. It was released last year in 2021, around the summertime. It sits somewhere between get and post. It's a get with a request body, but a post without modifying the request, the record. So it's a safe way to do query operation. So the payload, right, returned in the response to a search. Basically, you can assume it can be identified in a way. So next, let's talk about error handling, which is a fun topic, and the status code. Again, you probably have seen all those status code, right? 100, 200, probably you say it very often, and the 400, 500. So 200 means it's success, it's good, right? 400 means probably something we did something wrong from the client side, and the 500 is oops, right, server error. And how do you use those status code, right? One thing you can use it is to do your error handling. And you can actually do more. You can do analytics monitoring with those status code. You can set up your error budget based on the history of failing cases. So error budget is basically allowance, right? That you agree with your stakeholder for the application to fail if it's in trouble. It sounds great, right? But once you have set your error budget, then every minute count. What do I mean? So if you have a service and you're promising to have it 99.99 percentage, right, in terms of availability, it means you agree for the service to fail only 52 seconds in a year. that's like 4 to 5 minutes per month, which means if your service fail, you must get back to life within 4 to 5 minutes. Okay, so once you've done all these top 4 points, now you can actually do some nice functions to enhance your API design. You can add some pagination and some filtering. So imagine if you have an app, right, returns like 1,000 records from to make a list view, and it could be a quite bad user experience, right? So you could actually design in a way that it returns only a partial of it. That's where pagination comes in. You can load maybe top 10 data, and you can even preload the things slowly and caching it as well. So the user experience becomes really good afterwards. Or you can do some advanced search with filtering as well, sort the data before return it to the client side. You might wonder, right? Why can't we use client side to sort it? Well, we can, but there were multiple types of client app, right? There were iOS, web, Android, desktop, maybe tablet, mobile, right? So there were multiple types of work comparing to if we centralize it in the server side. And a golden rule is also to push as much as you can to the server side. So the client project should be a dummy layer just to display information and to interact with user inputs. So once you've done your API design nicely, right? Next thing I'm going to talk about here is API first. The concept of API is first class citizen. So up to now, we discussed how we design API and which applies to the entire project, right? Maybe it's something you do before you kick off a project. And maybe you do it once in a while when you want to give a new version of the API. But do you want to, so you don't need to design the API structure once it's properly defined. So now if we look at API design as in terms of day-to-day development, right? Because it's not enough just to have a structure of the API, we also care about the content and how the actual complexity of API design comes with the API content for our domain logic. So now let's think about API first in our day-to-day life. So API is a product. It's not just a tool. So we adapt the API first model where we can improve and enhance the development of a solution and make the process more agile. So imagine if you're in a smaller product team, the backend, the front end, maybe design API together. Or if you're in a larger company, there might be a separate team looking after the API design only. So no matter what the process you are following, API should be always considered as a first-class citizen, not just the structure of API, but also the content, the value that contains within each API call. So the implementation, right, of the API might change from time to time, but the API itself, it doesn't change. So how do we do API first in the agile environment? Imagine that we have Epic ready, right? The next thing is we sit together with backend team. We kind of break this Epic down into smaller pieces of stories. And now we should think about, right? Should we use a string? Should we use integer for certain type of data? Should we use patch? Should we use put? Should I receive empty response or redirect status code? Should the client side make 3 API calls to retrieve data for one screen, or can backend kind of combine this for us to make our life easier? So all these things we need to discuss before we dig into code, right? This is where API first applies. So the team should design API together and write down the test cases for it and document this API design. In this way, first you design the API, and the backend and the frontend can start working in parallel in a way, which is very efficient. So backend would implement API as empty shell and push that to frontend team saying, this is what we agreed, this is a contract we agreed. Now frontend team can use this empty shell to start building the frontend application. At the same time, in parallel, backend team can also implement the function of the API. So in this way, right, we avoid lots of delay. If one team is waiting for another, or maybe there are some changes along the way. So to both teams work together. And if there are changes, right, we can always communicate it quickly. So let's say, right, in this example, if this is a story we're going to implement, right, we want to retrieve the speaker information in events. And usually, if your backend team give you this API, say, this is API, just use it, right? As a front-end engineer, you should look at it, right, and say, does this actually give me more efficiency? Or is this like a nice way for me to render for my application? Can it be better, right? So always think about how we can improve the content. But ideally, always negotiate this beforehand with your backend team before this was given to you already. This is why API first is important. So next, right, once we have the API designed, once we have the content as well, we should think about tests, right? So if you look at the testing pyramid, at the bottom, it's always the unit test, which forms 85% of the entire project. With API, you can do API test, you can mock it, you can either do end-to-end test to do the real user journey, right, the whole journey. But there's another type of test called a contract test, which is designed properly to test your API and to prevent any breaking change got deployed into production that will break your front-end app. So contract test sits in the middle part of the test pyramid, which is part of the service test. You do either happy path and unhappy path with it because it doesn't really touch UI, although it connects both apps together, but it provides a very efficient way for you to do your test. And I will talk a bit more about contract test. So let's say if your API is a product, it's part of the project, so we should have it tested, right? So imagine contract test. It's a way to ensure service can communicate with each other. Any breaking API change can be captured early. It's part of the service test, and it's a lot faster than end-to-end test. So it tests the actual API. It's not test anything like mocked, anything, right? Mocked on the device or something. And it's shared between both teams to allow collaboration. And a very simple example, right? Let's say if we use this framework called PACT, P-A-C-E, right? It's quite a well adapted contract testing framework in the market. So both team, front-end team, back-end team, use this framework called PACT. So the consumer would create unit test, which generate a PACT file and upload it to the broker. So the broker is a middleman between the front end and back end, which then verifies the source of truth at the other side. Then the server, right, will download from this broker and run various unit tests and checks for validation and upload the result back to the broker. So you can always use contract tests to prevent any breaking API changes that might cause damage to your application. So that's end of my talk. I hope you like it. So yeah, happy to hear any of your thoughts or discussion, right? You have my contact here. And yeah, have a nice day.